Rotation of the radially slotted arm is governed by theta equals 0.2t plus 0.02 t cube, where theta is in radians and t is in seconds. So note here that theta is a function of time. Simultaneously, the power screw in the arm engages the slider B and controls its distance from O according to R, which is a function of time. Calculate the magnitudes of the velocity and acceleration of the slider for the instant when t is equal 3 seconds. Alright, so the velocity and acceleration magnitudes are required. So we need to find r dot, r double dot, theta double dot, so we can find vr, v theta, and also the components ar and a theta. So let's start with r, which is this function, and at t equals 3, it's equal to 0.56 meters. And then if we take the derivative with respect to time, first part goes away, second part becomes 0.08 t, and at t equals 3, it becomes 0.24 meters per second. And if we take the derivative also one more time, t goes away, we have a constant r double dot, which is not changing with respect to time. It has the same value of 0.08 meters per second square. And for the theta part, theta is a function of time. So at t equals 3 seconds, and this is where the velocity and acceleration are required, theta is equal to 1.14 radians. And theta dot, we just take the derivative, and then the value at t equals 3 is 0.74 radians per second. And taking the derivative one more time, we find theta double dot, which is 0.12 t, and at t equals 3, it has a value of 0.36 radians per second square. And now to find the magnitude of the velocity, we need vr and v theta. So vr already found, which is r dot. V theta is r theta dot, which is 0.414 meters per second. And if we find the magnitude of both components, it becomes 0.479 meters per second. And for the acceleration, it's also a straightforward application. So just apply the values for ar, a theta, and then find the magnitude, which will happen to be 0.601 meters per second square.